All right, folks, so today's craft or experiment is going to be a little bit crafty. So I hope you can tie a knot, and we're going to be using some scissors today. So to begin, do we all have a milk carton? It doesn't have to be milk. It can also be juice or anything. It's just one of these 2-liter cartons, like this. All right, so what we are going to do today is make a well, or a water well, out of a milk carton. So does anyone know what a water well is? It depends. The 1.75-liter bottle, it depends how the bottle is made up and structured, because the way we're going to do it, we're going to cut holes through here, but not here. So we kind of are looking for a shape like this. So if you can make it work, for sure. But the ideal is the milk carton here. Yours is plastic. Well, as long as it works, and if it doesn't work, we're recording it, so you can try again with whatever you have and get milk. So yes, the well has been around for a long, long time. And so wells can be made by digging, drilling, or driving. So driving is driving pipes deep into the water. Drilled wells are like the rotary machines where they're drilling in, and then you can just dig a well as well. So a lot of wells, there's still wells all around the world. Some of us, even friends I have. Does anyone here have a well still at home? Or they live on well water? Everyone's on city water? I'm also on city water, but yeah, some people still. So wells are very, very useful to this day because you need your water. So, like I said, the first thing we are going to do is cut squares out of the front and back of our carton. So the idea is, I would recommend, my carton's black, so it's a bit tricky. You just want to make a line, put a line. Let me try a highlighter, see if that looks a little better for you. But what we are doing is cutting out 2 squares. So just cut here, here, full square, just like this. So you'll be able to put your hand right through it, but it still has the structure on both sides. So how we're going to do that, we are going to use our scissors and kind of just cut the edge of our carton, and then be careful and just cut. So I cut here. It's okay if it's not perfect or it gets a little bent. How do you cut it? Well, you cut into the corner with the tip of your scissors, or you could poke it with a pen or a pin, something if you have it. Any way to get a little cut. If you need help, maybe ask your parents. And then you cut down. And so I will finish my first. A pencil, if you can make a hole to get that cut going, go ahead, by all means. Cutting down. It's kind of like right now, it's looking like a little window. I have pretty much cut. And so I have one part done. And so I have just cut a square out. I did the back. So we're doing the front and the back. And so now, how high? Well, you want it so it's about, I would say you have about 3 thumb widths from the top, not the tippy top, but the top of the rectangular base. About 3 thumb widths down. You're done? Okay, I still have my other side to cut. Okay, now I have my two sides cut. One side looks slightly bigger than the other. That's okay, not a big deal. Yep, it's okay if you can't, if you fall a little behind. Like I said, you'll be able to watch the video afterwards, so no worries at all. So our next step is I have our total milk carton. All that has been done is 2 squares of the same size has been cut through it. What we want now is we are going to put holes in both sides of our structure a little bit lower than where we first cut our square. So I'm going to show you what I want. So you poke a hole through, and then we're going to feed a pencil through. So you want it to look like this. You see that? So you either just use a pencil, a pen, the tip of your scissors, and just put a hole. This is actually one of the most important parts of the well, because it is the shaft. And so the shaft is what's going to make our well, a simple machine, it's called. So I'm putting my 2 holes through the 2 sides. How's everyone doing? Staying with me? Am I going too fast? Going too slow? How are we doing? Good? Good. A little fast? Okay. The whole room smells like juice now? Well, I hope the carton was empty when you started. Okay, so I have my 2 holes. And now I'm taking my pencil and I am simply feeding it through. A little fast. Okay. So now I have my carton and we have it like that. So I'll leave that so we can kind of see it. And so the reason that this pencil part is very important is because it is what's going to make our water well a simple machine. So does anyone know what a simple machine is? No? So kind of. I'm sure you do. So a simple machine is it's a mechanical device that is changing the direction or magnitude, like so the size or direction of something, but it's only one force. So it's a very simple machine in a sense. Two things you probably heard of are, so a pulley. That is one way we could have set up our well, a little pulley machine. And so can we name any pulleys that are in our houses? There are tons of pulleys in our houses. And so it doesn't have to be exactly that. It could be a pulley system and it's built on something else. And so what's a pulley? A wedge is a simple machine, yes. Clothesline, yeah. Window, yeah, exactly. So like the blinds to raise the window. Yeah. If you were raising a flag, that would also be it. Extending a ladder, you know, when you extend the ladder, rope pulls in the pulley and the ladder shoots up. So it's exactly like that. Now, our simple machine we are kind of using today for our water well is a wheel and an axle. So it's a wheel and an axle, and that's what it's called, and they go together. And so these are also all over our house. Can us name any wheels and axles in the house? A car? Yeah, well, there are axles on the car wheels. So that cars are very intricate, but you're exactly right on the money. And so I'll show you the photo one more time. Some things are a wheel and axle even when I was looking at it and I was Googling it. Fridge wheels? Not quite. They're definitely a wheel, and depending on how the fridge works, I guess technically it could. So you're not wrong. You're definitely not wrong. So thinking of wheels and axles are like a merry-go-round, even a screwdriver is a simple machine and technically a wheel and an axle because your axle's the screw and you're spinning it, that's your wheel. Another thing that's a wheel and an axle is a doorknob because your doorknob is your wheel and you have your axle there, and when you spin it, it opens. And so, yeah, a lot simple machines are everywhere. And so that's why they're also with our water wheel. So are we all caught up to this part? Yeah. Okay.
I think I'd try out doing maybe a poll. I think your economy is going to try it out and see where everyone's at. Does that sound good for you guys? You want to try that?
Let's try a poll out.
We'll see if it works.
I feel like everyone that's saying no is probably busy trying to put their experiment together here, aren't you?
Exactly.
Okay, so don't worry because I'm giving you options for things we're going to make here. So we're going to move on to making the bucket real quick. But like I said, you'll know how to make your bucket once you get there. And if you aren't behind or you're a little behind, we'll still be recording. So I'm not really moving forward. We're just moving to a different step. So I know it's probably tricky piercing the sides here. So we're going to make our bucket now. And I told you that I wanted a pop bottle or a toothpaste cap as your bucket. And so that is what I have here. But you could also use a little Dixie cup and say a paper clip. And you could make a little bucket out of that too if you struggle with tying rope around your bottle cap because it is a little tricky. So the other way I can make a bucket, which is the way I did it, is you can take some tape or glue. I know glue takes a little longer, and you could glue or tape your string inside the center of the cap. Or what I did is I took a piece of a toothpick, just a piece of a toothpick, and if you bend the cap slightly and then you stick the piece of the toothpick in, the cap's going to bend back and it's going to hold the piece of the toothpick. And so it's pretty easy like that. And then all I have to do is tie the rope around right here. So in case your resources are limited, your two options for the bucket could be toothpick and a cap, or taping, gluing onto the cap, or we are having a Dixie cup and our paper clip as well. You don't get it? Okay, so I'll go over one more time. These two items are going to be our buckets. So you can kind of make them either way. I'm just giving you options. And so two options are the Dixie cup, because it's paper. You can just pierce it really easily with your paper clip, or you take a toothpick or a piece of a barbecue skewer and you could put that in between by just squeezing the cap, putting it in, and then the cap comes back and it stays in there. Yeah? Perfect. Okay. So if we have made our cap and we have our axle here, what we need now is to tie, or tape, or glue. It's up to you. What I am going to do is, so we need to tie our rope in two spots. We need one spot that's going to be around our axle here, and the other end will be tied to the end of our bucket. So it doesn't really matter what knot you are doing, make sure it's tight. You might have to cut your string, so I recommend tying the bucket first, and then you can measure out how much string you need to tie to the part that's attached to the well. So I am going to tie. If anyone is speedy, feel free to name any other simple machines that you might have thought of now that I've described those two in the chat. We also mentioned things like screwdrivers or wedges are. You think of a teeter-totter. Inclined planes, that is very true, an inclined plane. So an inclined plane, it's a lot like a wedge if you think of how they're built. Do I use a cap or a cup for my bucket? Screw, lever, correct. Well, I use the cap, but you also could use this. I'm just giving you options because in case someone didn't have a cap at their home, but they had a Dixie cup and paperclip. So make it how you want. You could make your bucket a different way if there's a way you think is better. This is just how I thought were two pretty easy ways to make your bucket. So I now have my little bucket tied on my rope. How do you attach the cap to the string? So you can either try to tape it at the center, glue it, that will take time. I took a piece of wood, I think it was from a barbecue skewer, you could use a toothpick, and all I did was squeeze the cap and then place it in, and then when it closes, it kind of seals, and it seals around it, and so now it won't fall out. Yes, and if you want, you can always just tie a bunch of rope around your wheel, or your well, or your bucket, if you want. It might not come exactly straight, but it'll still work, and when there's water, it'll catch because of the force. Perfect. So my next step is tying it to this part. Get it nice and tight. Depending on how big your knot is, your rope might not catch as easily when going up. So try to make a big knot, but it doesn't have to be huge. How long for the rope? I would say if you cut 2 feet, that would be plenty. And you'll probably have to trim it a bit. No problem. So I am tying my rope. I'm going to tie it once more. Okay, so I have my rope there, it's secured. Cool, and I'm going to trim my rope a little bit. All right. So now, you could finish here, technically, because if it spins, it will work. But this just, in a greater, bigger design, it wouldn't make sense to have something that you can just turn with your hand, because that's really hard. So the next part we have to make is, we have our shaft, we want to add our wheel. So we're going to make a little thing that uses a crank. And so that is going to look like, maybe like this, where it's just a piece of the recycled cardboard. I'm going to make one with you. I'm just showing you a couple. It's a piece of, because we have some cardboard lying around, right? Because you just cut out the 2 squares, so you have some left over right there. And so I have a sheet here. And so what we're going to do first is to make something like this, we just want to cut an oval out. And so the size of the oval, I would say about 4 or 3 thumb lengths long and like half a thumb length less wide. And so I am going to literally just draw an oval for my crank, because this is what is really regarded as the wheel of our simple machine, is going to be this piece of this oval that is cardboard. So we cut our oval. And so I have my oval cut like this. I made it a little bigger than I drew it. I didn't mind. And so as soon as you have an oval cut out, you are going to want to put a hole in the center. Right in the center of the oval, you'll probably just want to use a pencil or something like that. It's okay if it gets a little bent, that's no problem. And so you want your oval to be, or you want the hole in the center of the oval to be as big as a pencil. So because it's going to attach to the end or one of the sides of this, so right here. So you want it to be as big as that. And exactly, if you're finding this experiment overwhelming or busy, you are more than welcome to just follow along with me now and rewatch it later. That way, it's no point in rushing something. You want to make it as nice as you can. So I have my oval here. And so it kind of looks like a wheel and an axle now. If you think about it, we have our wheel here and we have an axle, but the wheel can't really spin very well. So what we do is I recommend just cutting a little piece like this. And so what I did is I have my hole, but now I also cut out a little sliver. So that is what is called a crank. An oval works a little bit better. You can do a circle, but I like the oval just for the length of the crank here. But many shapes would work in this situation. Yeah, so you can make it bigger if you want. It just has to, you have to make sure it's tight enough so that it'll spin this. If you have trouble with this part and it's not spinning, reminder that you can spin it with your hand and you still get to see the simple machine at work and it pulls up perfectly. And so if you're wondering why the rope here it grips, it's because you're thinking of something related to the force of friction. And so friction is a force that comes when, or something that slides forever has no friction force on it. It's like even on ice, there's a very low friction factor on ice compared to concrete. And that's why you can spin. And yes, so it coils around. But the fact that it coils around instead of just slipping every time is due to the force of friction on this rope because the mass. And so that means the mass going down has a greater force. Does everyone get that? So don't worry if your crank doesn't work. There's also other ways you can make a crank. I put a hole here and I also used a little, again, piece of a barbecue skewer. And so that fit pretty well and it feels a little bit more authentic when you're spinning it. Just a little bit. So who's caught up? still working on it. Nice. Make a pull? Okay. Can we make a pull? Nice. So we're not going to fill up our wells with water today, because you can do that on your own time if you want. If you want to make it more authentic, what we can do is when you put the water in, you could also put in some rocks and stuff like that, because the way we acquire the water, the resources underwater, is the buckets are going into water, but it's through something called permeable rock. And so permeable rock is when the rock is, there's water still seeping through. Something permeable means that it isn't completely solid, like something can soak through. So thinking of a sponge or something like that, a sponge is very permeable. Oh, authentic? Authentic means like real. So like an authentic signed baseball card, it's real. It's really signed. So folks, we are done with the well today. I hope your crank worked. If it didn't, if you had trouble with the crank, I found the bigger the hole I made here, the easier it was for the crank to turn, because again, there's no force acting on this as much if it's a larger hole compared to a really, really tight one. Okay. So if you didn't get the well, that's okay. I know some of us don't do the activities every week at home. We will be on YouTube. I hope you enjoyed this one. I think it's pretty cool how simple little machines like the pulley or the wheel and axle can do so much. So you also could have done this the exact same way with not a wheel and axle. A pulley would work just the same, would it not? It wouldn't be as easy to keep the rope because the rope doesn't coil up. But yeah, so if I did the pulley, all you'd have to do is manually, but there you go. And that, again, is a simple machine, because all I have is my force, that is my hand, and we have the weight, that is our cap.